The Devonshire Building, completed in 2004, is home to Newcastle University's Institute of Research on Environment and Sustainability. The building provides a laboratory and office space for both departments. In keeping with its function, the building was designed with state-of-the-art systems that enable it to be environmentally sustainable. The Devonshire Building became the first building of its type to receive an excellent BREEAM rating.
The story of the Devonshire Partnership begins in 1900 when Robert Ridley Kitching formed his own architectural practice in Middlesbrough. He was joined by Richard Archibald and William Lee in 1904 and 1905 respectively. Kitching, Lee and Archibald was formed. In 1930, with the addition of more partners, the company became Kitching & Co. They continued to develop a quirky architectural style which is summed up in the Sparks Daylight Bakery, Stockton, an iconic Art Deco meets modern building, which was threatened by demolition in 1985, but luckily saved and converted into luxury apartments. In 1967, the partnership reformed as Darnton, Elgie, Wrightson, Jackman and O'Connor. In 1990, with many of the partners moving on, the company was officially restyled as the Devonshire Partnership. The new millennium marked 100 years of continuous architectural practice. The partnership worked on a great deal of projects across many industries, particularly healthcare, education and biopharma. Notable examples include the Carr Green Road and Ring Cross Estate residential developments, Net Park and Monks Eaton Community High School. In 2009, the Devonshire Partnership was acquired by DeVril Architects. The merger created one of the UK's 20 largest practices with 150 staff in the UK and another 250 across Europe.
The Devonshire Building is situated on the Newcastle University Campus to the southwest of the A167. It is to the northwest of the city centre and has a frequent bus service between them both. The site is also around 400 yards from the Haymarket metro station, which along with the bus service provides an easy route between the city centre and the Devonshire Building. There are pedestrian routes between the Devonshire Building and the city centre too, and there are also many well-defined arterial routes between the university buildings and the Devonshire, making it easily accessible. There are 63 parking spaces surrounding the Devonshire Building, the majority of which being roadside parking, but there is a car park next to the building that has disabled parking spaces. Surrounding the building are several seating areas which during the day are in the sun, and the main entrance is situated on the west side of the building and is easily visible from the main road and the main pedestrian route.
As the south side of the Devonshire Building receives the most sunlight, the exterior cladding has been fitted with louvers. This enables the occupants to create shading which is customisable depending on the time of day and the use of the space. The north side of the Devonshire Building is being used for research labs, and so it's imperative to be able to create spaces where the light and temperature can be controlled. Being located on the north side of the building, the rooms are sheltered from the solar gain by the building's shadow. This enables the lab's environments to be artificially maintained without being affected by the sun. The north elevation also contains all the external services. This is because this side of the building requires less glazing and therefore they don't block the light getting into the building. As you can clearly see from this west-facing section, the north side of the building contains the research labs along with the services. The central space consists of the main atrium that rises the full 6 floors to the roof, and the south side of the building houses the office spaces as it receives most of the light. The ground floor of the building has 2 entrances, one on the west side of the building, which is currently the main entrance for students and visitors. This leads into the main lobby area. And the second entrance to the north side. This is for authorised personnel only and gives access to the plant house on the ground floor. This entrance also doubles as a fire escape for the stairwell. The lobby takes up most of the central space on this level and contains the main reception along with informal seating for eating. The ground floor also contains 3 large lecture theatres and some meeting rooms. The first floor is accessible from the lift at the east end of the lobby, or the 2 staircases at the east and west ends of the building. This floor contains office space to the south and the lab space to the north. Toilets and services are at the east end of the floor. The first floor is the start of the lobby staircase that runs all the way to the 5th floor, providing easy vertical movement for the west side of the building. The 2nd to 5th floors are all accessible by the lobby lift and the stairs or the east and west staircases. All the floors are centred around the central void leading down to the lobby. Again, like the first floor, these floors consist of office space to the south and laboratories to the north. All the floors have toilets at the east side, as well as casual seating areas and spaces for food and drink preparation. The lower roof level is accessible from either the west or east staircase, and it contains most of the building's plant, most of this being for ventilation and air cooling. The upper roof level contains the fume extractors for the labs. The photovoltaic cells are also positioned on the upper roof, as well as skylights which provide natural light all the way down the centre of the building to the lobby floor.
The Devonshire Building has many technical aspects within its structure, such as sustainably sourced and renewable metals. These aspects provide a sustainable and a functional environment. 400mm airfoil fins were fitted with steel bow trusses. This was to provide shading to the glazed southern elevation of the building. This motorised system are controlled by light sensors and a Levelux multi-controller. The louvers are climate responsive and allow optimism of daylight and solar penetration according to the time of day and the season. Aluminium airfoil fins. The Levelux range of airfoil fins provide an extremely efficient external sunscreening system that can also enhance the architectural appearance of the building. Levelux fins are non-retractable and can be installed to provide protection to vertical, horizontal or inclined glazing. They can be installed in a fixed position or can be adjustable manually by motor with switch control or with a full automatic system, which can be integrated into the building management system. A fully automated Levelux aluminium airfoil fin system can reduce solar heat gain through the shaded area by up to 95%. This decreases the need for air conditioning, therefore less energy is used. Also, it improves the internal environment and the comfort levels. Large airfoil fins allow a significant level of natural daylight to enter the building whilst reducing solar gain. Additionally, the wide spacing allows good outward visibility with less clutter to the sightline. Furthermore, they fit in well with the concept of natural ventilation and provide excellent control of the internal environment if controlled automatically or linked to the building management system. The accessibility of these in order to provide access for maintenance. Levelux aluminium airfoil fins can be integrated into the facade system, incorporating walkway, handrail and latchway system. A Levelux multi-controller. A Levelux multi-controller employs the most up-to-date microprocessor technology for the control of a wide range of the solar shading systems. It is compatible for operating up to 4 independent groups of mixed blind types, signals being received from up to 11 linear sensors and 2 animators. In addition, fault-free contacts allow signals to be received from manual switches, fire alarms and building management system. A Levelux multi-controller also incorporates a digital clock, allowing the control of shading systems to be switched from manual to automatic control at user-defined times. Standard software is available to control of roller blinds. The system is easy to use, with all inputs and commands being entered via a digital keypad. Using a simple menu system, the configuration and status of the shading system that is being controlled can be observed on a backlit display. For the Devonshire Building, this display is implemented on the right-hand side of the entrance. Other sustainable aspects, such as the photovoltaic panels which have been implemented to the roof, which generate 30 kilowatts of power. Aquatherm pipework made from 100% recycled material is fitted, rather than the traditional choice of copper or steel pipework. The building's approach to sustainable energy also utilises an impressive floodlighting system to illuminate the building at night. The system uses approximately a fifth of the power that would normally be required using conventional floodlighting.